What is up, guys? This is Luke Hill for Kit Guru, and in this one we're going to take an initial quick look and a hands-on with Zen 3 and Ryzen 5000 mobile form. Now, full disclosure, we know that the chips have launched by now by the time you watch this video, but there were some sampling issues in Europe, so we're still working hard to get the review done, to have a look at the comparison data, but we thought it'd be interesting to give you an early hands-on to see just how powerful Zen 3 is, and to also look at some of the really quirky features with the 35-watt Ryzen 9 5980HS in this ASUS Flow X13 laptop. Let's dive into it. But before we do that, if you like what we do here at Kit Guru, make sure you like and subscribe to the YouTube channel. That really helps us out and make sure you're up to date with the videos that we put out. Head on over to the kitguru.net website, that really supports us, and you can buy a cool t-shirt like this from our merch store. Check out our Patreon page and keep in touch with us on social media platforms. Let's get back to it. So I'm just going to quickly run through some of the specs of the Ryzen 9 5980HS because that's the specific Zen 3 chip that we're interested in here, that we're testing. Like I say, the full review is being worked on and coming up, so make sure you check out that and you can get more details when that's ready. But the Ryzen 9 5980HS is basically the 8-core 16-thread processor. It's the second in command, if you like. The HX is the highest end chip, and it's a 35-watt TDP, 3 GHz base frequency, lofty 4 GHz plus close to 5 GHz boost frequencies, 16 megs of L3 cache, all that Zen 3 goodness. Obviously it's an APU, so it's technically got graphics baked in, but we're not all that interested in that here because we've got a more powerful discrete graphics card. But anyway, I think that's a pretty decent introduction of the Ryzen 9 5980HS. That's enough of me talking. I know nobody wants to see any more of this. Let's get hands-on and see how the chip actually operates. Clock speeds, power, performance. Okay, in this one, so we're going to do a quick run of Cinebench R20 side by side. So we've got the Razer with Tiger Lake, we've got the ASUS with Ryzen 5000, and we've got the MSI with the Core i9 10980HK. So let's have a look. I'm going to try and be as quick as I can. I'm going to run the Razer first because it's going to be the slower, so I'll give it a slight advantage. And there you go, they're all running. So what we'll do is we'll just watch Cinebench R20 running in real time. You'll hear some of the fans spin up, most notably from the MSI, that's the hot and heavy one. And also you'll notice that because of the different screen resolutions, you can't really see the tiles properly. So I will point out when each of the devices finishes the Cinebench R20 run. And of course, this is just standard Cinebench R20 that you can run on your own system for comparison. For the Razer, we've got it in the gaming profile, so that's roughly 28 watts or 30 watts or so. Package power for the CPU. For the ASUS, we've got it in the turbo mode, so we'll get back to what it does with regards to CPU power later on because it's kind of quirky. And for the MSI, we've got the i9 running in the balanced mode, which gives it a roughly 45 watt long duration TDP, or package power if you like. So at this point, it looks like the ASUS with the Ryzen 9 5980HS is winning. Wow, okay, it's finished. So what's that? 48.59. Now, of course, I'm going to run some more data and some more tests for the actual review to make sure you check back for that. And they'll have some revalidated data with no monitoring, etc. in the background, so it'll be clean and efficient. Check back for that. But that's looking like quite a convincing victory for 8-core Zen 3 at the moment. Clearly, we can see the 10980HK is not too far behind, so it's coming up, it's almost finished, and we can hear the fans have turned down a bit, so it's probably running a bit cooler at the moment with a lower package power. That is finished. What's that? 31.52 points, and the Razer's still running. That's going to be there for a while. Tiger Lake's only 4 cores, we know it's quite a bit slower. So I've given a brief bit of time for cool down. The ASUS has had a little bit more time than the MSI, but I'm not too concerned about that because I know the way the MSI operates and the cooling system is very proficient there, so I'm not too concerned. And what I'm going to do now is just rerun both tests, and then we're going to look at the clock speeds and the power behavior while the tests are running. And I think I messed it up. Whoops. There we go. So if I load up there and there, let's have a look for the ASUS. And if I just do that, touchscreen laptop. So we can see that the 5980HS initially jumps out to about 3.7 gigahertz, about 54 watts of package power. The 10980HK, that's running currently at about 48 watts, I imagine. Yes, 48 watts package power. Clearly you can see I've been using this quite a bit. About 85 degrees Celsius for the CPU, but that depends upon the fan speeds that you choose. And the frequency is a little over 3 gigahertz. So very similar to what we saw from Cinebench R20. that 48 watt package power for the Core i9, 3 gigahertz roughly on all 16 threads, and your temperatures are kind of mid 80s, whatever, that's fine. We know the Intel chips in a laptop can do 99, no problem. On the AMD side of things, 3.7 gigahertz on all the 16 threads, and we've got a CPU package power, PPT specifically, of about 54 watts at the moment, with a CPU temperature of about 85 degrees Celsius. So funny enough, they run at the same CPU temperature, but you know, whatever, that's a variable design target depending on the cooling system. And the ASUS system is done. And I'm just going to stop the MSI because all we wanted to see basically is the clock speeds, the temperatures, which are not all that important because of the different cooling systems, but then also the package power draw. So what we can see is 54 watts Ryzen versus 45 to 48 watts Core i9. The Ryzen is winning very, very comfortably. So let's remove some of the shackles, shall we, on the Core i9 system with the bigger, beefier cooling and see if this Ryzen chip can still keep up. So what I'm going to do to remove some of the cooling and the performance shackles from the MSI system in particular is just going to use a scenario, go into extreme performance mode. This is going to ramp up the fan speed. So actually we can see that the Ryzen 9, the Zen 3 chip, is taking another lead at the moment by the looks of it. Yeah, this is going to win on the Ryzen 9. Wow, so we've got the Ryzen 9 again, kind of 12,400 points. And we're still waiting on the Core i9, even though we've ramped up the power budget and therefore in turn the cooling capacity delivered by the MSI laptop and the frequency that the chip should be operating at. So that's quite a strong victory, I would say, for the Ryzen 5000 chip. Quite a strong victory indeed. And we've got 9,400, so that's about 3,000 points down for the Core i9. So if I just do that off the top of my head, that's roughly a 30% performance improvement going to the 5980HS. That's a strong victory for AMD. That's a really strong victory, especially in this sleek, slim and light chassis. But let's have another look and see what the Intel was doing with regards to clock speeds. So this is starting out, right, so it's ramped right up. We can see the temperature's gone red. It's 95 degrees package temperature. The package power, oh my word, okay, 85 watts package power. It's now coming down kind of 77 watts. This is on the Core i9, of course. 70 watts package power because those temperatures are pretty high. We're talking 3.5 gigahertz, so about 3.55, 3.6 gigahertz clock speed on all 16 threads. Still 95 degrees Celsius, I can hear the fans ramping up, and the package power is now at about 67 watts, so kind of 65 watts. I expect this to still continue to go down a bit further. The PL1 power limit is saying 58 watts, and I think that's pretty accurate. So based on some of my testing, we're talking about 56 watts, kind of spoiler alert there, 56 watts sustained long duration power limit for the Core i9. And as we can see here, the ASUS Ryzen 9 5980HS is running at 54 watts sustained at the moment. So yes, we still see the Core i9 dropping down a bit more, 63 watts package power at the moment, and that's 3.4 gigahertz on the Core i9. And well, okay, the ASUS is done, so I guess I can't really comment on that at this point, but we've seen this operating mode quite frequently anyway. So at this point, I think I'm pretty confident in saying that the 5980HS, as far as multi-threaded rendering Cinebench type workloads go, is way faster than even a 10980HK in quite an aggressive power state. Let's have a look at some other factors though with respect to the 5980HS, as it has some quirks in its performance operation modes. So what we're going to do in this one is I've got the 5980HS of the Flow X13 set up in turbo mode. So this is a somewhat more aggressive mode, of course. And I've got the screen rotated, and this was an indication of a point that was pointed out to me by AMD. They said that you shouldn't really operate in a 90-degree orientation because it blocks the vents and can cause some quite significant cooling issues, which is, at this point I'm going to call that interesting. Let me know in the comments section down below how you'd refer to that design quirk, shall we say. But basically they say roughly 110 degree screen orientation, allowing a bit of flow to get through to the vent. Whatever, I'm going to test like that. Let's give it a go. And here I'm actually going to test the 10 minutes or throttling test for Cinebench R23. And I'm going to keep an eye on the clock speeds and the package power and basically just the operating mode of the CPU. So that started. Leave it run for a few minutes and then I'll make some comments. So I've got the Ryzen 9 5980HS in the Flow X13, and we've been running Cinebench R23, the 10-minute stress test. It's been running for about almost 2.5 minutes. And what we can see is some really quirky behavior. So we have explored already, shown that this processor will run at about 54 watts package power during the operation for Cinebench in the turbo mode of the ASUS Armoury Crate. However, we're still in turbo mode, and if we just watch the package power, we can see that it's very, very dynamic. Now, this is understandable. We expect it to go up and down as some of the factors with the system change, but we can actually see some quite significant throttling. And the reason I'm going to call this throttling is we can see right now it's running at 3.9 gigahertz, that's flying. The package power is somewhere in the order of 54 watts. We can see it's kind of jumping up and down as we expect. HW info has a slight delay based on the sampling rate. Bang, it's going down to 70% utilization at 2.4 gigahertz. That's a throttle because that's 600 megahertz, 20% below the 3 gigahertz base clock of this chip. So what exactly is going on? Why is this chip throttling when the temperatures are absolutely fine? 89 degrees. 89 degrees is absolutely fine. That's no problem at all. This is a laptop after all, a laptop CPU. And then bang, we're throttling and we're down at 80 degrees. Really, really odd behavior. Let's keep an eye on this one. The APU, the STAPM. So the STAPM is the skin temperature aware power management. And this is basically one of the sensors in AMD's, I must say, very smart and perhaps complex, perhaps in-depth, depending on your perspective, suite of sensors. So what we actually see is that this power sensor cycles up as the PPT, the package power, is cycling up. It cycles up, and then it hits a threshold, and it forces the chip to throttle down to 2.4-ish gigahertz. And then it hits underneath that 20-watt target, and bang, it allows the chip to spool back up to full frequency and full power. As I just continue to play this in Cinebench so that you can see this somewhat unusual, if you like, cycling behavior. And the reason I call this somewhat unusual is because with a conventional desktop platform, or even with some of the Intel platforms for the laptop CPUs, you wouldn't really see this reduction in CPU utilization. How you would observe system throttling is you'd still see 100% CPU utilization, but what you would observe is that the frequency, the clock speed of the CPU is dropping. So the clock speed is dropping to handle the throttle, whether that's a VRM throttle or a temperature throttle or a power throttle. The clock speed is dropping, but you're still using 100% kind of in quotation marks, all of the resources available to you at the CPU. So the fact that it's dropping in Windows, dropping the utilization, is quite unusual from conventional logic, if you like. And I'm basically just going to refer back to some of the notes from AMD's Ryzen 4000 technical seminar last year in February. So some of the points that they highlighted was this new suite of sensors, the STAPM, or Skin Temperature Aware Power Management System, kind of uses some of these sensors. And you've got the STT-V2, so that's the system temperature tracking. So basically AMD is allowing partners and OEM vendors such as ASUS to use this suite of sensors to control some of the power configurations and some of the power management for the APU specifically. So basically, if I read off the AMD slide, what STAPM does is, and quote, STAPM enables high boost by budgeting CPU power versus a sustained limit. And I'm just going to rerun this test just so we can still see what's going on. So basically, what AMD is saying is they're allowing the CPU to ramp up to quite a high power level, and then if needs be, kind of somewhat instantaneously throttle the power level back so that in turn you get a greater average power delivery to the CPU, and in theory a greater average frequency to the CPU. Now this, on the face of it, seems like a pretty good idea, but what we can see here is when we're dropping 1400 megahertz in the click of a finger very, very quickly, and then in a second or so, so where do we go? So there you go, and then when we're adding another 1.5 gigahertz increase, that's quite a big difference. And I personally am going to say at this point, I do wonder how that will influence gaming, because if you're changing your frequency by 1400 megahertz or 1.5, 1.4 gigahertz very, very quickly, that's going to be interesting for the system dynamics when you're talking about frames per second and those type of behaviors where the human eye, the human interpretation is very clear. not necessarily a rendering job where you just put an input and then you look for an output. The benchmark that cannot be named at risk of the YouTube algorithm penalizing us is now running. So if we have a look at effectively the full power mode and we keep a look at the actual rays per second, we're at 54 watts, our frequency is about 3.9 gigahertz with full speed and we're about 4 million. Now you can see we throttled down to 2.6 gigahertz, we're throttling on the power, we're down about 2.9 million, so we lost about 25% of our performance. Let's have a look if that goes back up. And when it goes back up, let's have a look at if the power so it's ramping back up. We can see the power has ramped back up or is on its way back up and the frequency has ramped back up. So this is a good real world indicator of how you will see that cycling performance in a test like this. Now, of course, this is a rendering test, so fundamentally what the system is doing in between the input and the output you don't really care about. But if you're dealing with real-time system usage, for example, perhaps in video editing where you're really pushing the system hard, but this could be quite quirky behavior if you're losing about 25% of your performance in short bursts that are cycling up and down. Let's just see if this continues. So about 4 million, yeah, there you go, and we're dropping down below 3 million. So clearly this is affecting the average. We're not all that interested in averages here. It's the real-time performance that is quite interesting and that is really getting highlighted and hit pretty hard from this unique system behavior and the cyclical behavior between the high package power and high clock speeds and the reduced package power and reduced clock speeds. So what we're going to do here is I'm just playing some Grand Theft Auto and we can see the monitoring, or the system monitoring on the screen. So I'm just going to keep an eye on the CPU, the power targets, the actual package power and the clock speeds. And what I've done here is I've turned VSync on to try and reduce some of the load on the system. So we can see the CPU is running at about 4.25 gigahertz according to Task Manager. But if we actually look at HW Info, we're seeing it's about, well, because of the per core differentials, we're talking perhaps 3.5 gigahertz in some cases, then bouncing up to kind of 4.4, 4.5 gigahertz, 3.7 gigahertz on some cores. So it's quite bouncy. And I'm seeing that the CPU package power is about 35 watts. What I want to see now is if I increase the load on the CPU by basically turning off VSync, and this is going to force some more load on the CPU and GPU, of course. I want to see if this does eventually change the CPU into a throttling state. So we can see we're at about 100 FPS now instead, so we're quite a more significant load. If I just steal this car, of course, you can see the CPU package power is kind of 40 watts or so, so 43 watts. So it's climbed, but it's still climbing about 4.3 gigahertz. And it'd be interesting to see if we do get any form of throttle down to the 3-ish gigahertz region. So we're still running at 43 watts, and our STAPM sensor is absolutely fine at the moment. But there you go, we have a throttle. So we're down at 3.3 gigahertz, and you can see our frame rate is reduced. So it looks like that 20 watt STAPM limit for the CPU is in effect, and basically the CPU is operating at about 20 watts package power, which is about mid 3 gigahertz frequency. So now what I'm going to do is I'm just going to turn VSync back on and see if this has any effect on the CPU, because in theory if we reduce the load it might change the way the CPU operates for a bit. So basically, even as we go into the start menu, that reduces the load on the CPU and load on the overall system, because we're basically in the menu not really rendering anything, and this gives a bit more headroom for the chip. So what we see now, when we come back out of this, and granted VSync is on, we're up at 35 watts package power, 4.3 gigahertz frequency according to Task Manager, and kind of 3.6 to 4.5, slightly bouncing and slight differences between cores, but we are seeing quite a big difference in the CPU operating power state. Temperature's running kind of 75 degrees. I can hear the fan speeds are cranked up a bit higher to dissipate the extra power, the extra heat from the system. And now what I'm going to do is go back and see if we go on a higher frame rate mode. So basically back again, disable VSync and see if the extra load placed on the system is going to cause that CPU to drop down because of the change to the averages. So we're still at 4.3 gigahertz at the moment. The CPU's plowing away at, was it 41 watts, 42 watts. So if I just stand still actually, and just look at some render, 96 FPS, and now we're starting to see the CPU, bang, there it goes. The CPU's dropped to 20 watts package power, and we're talking about 3.3 gigahertz, 3.4, 3.5 gigahertz average across the cores. This reduction in CPU frequency doesn't really affect the frame rate all that much because the power budget is allocated over to the GPU so that it can run a bit faster. However, for a CPU specific workload, it could be an interesting factor to keep an eye on. If I just jump back off this, have a look at the frames that we're rendering, about 100 frames per second at the moment, package power about 41 watts, clock speed average about 4.3 gigahertz on the chip. We're 90 FPS now, and we're 20 watts, and we've lost about a gigahertz on the package power. Very interesting dynamic behavior. Well, I think that's given a pretty good initial hands-on overview of our current time with the Ryzen 9 5980HS. Like I say, our full suite of benchmarks and testing will be available in the full review, but hopefully this initial quick hands-on has given you a quick interpretation of how Ryzen 9 is looking in the mobile form. It's looking pretty good indeed. This 8-core 16-thread chip is significantly faster than the 10980HK, which we know is a very powerful Core i9 processor from Intel, very power hungry, high clock speeds, very powerful, and quite frankly the Ryzen 9 has absolutely blasted it in its 35 watt HS form. 35 watt with an asterisk of course though, because what we've seen is some of the power dynamics and the operating dynamics, especially in terms of clock speed, are really unique on this ASUS ROG Flow X13 laptop. At the moment, it's not all that clear whether that's just a quirk of this laptop and some of the software implementations or the BIOS implementations that ASUS has designed and put in there, perhaps some of the sensors that ASUS has applied to the laptop from AMD's quite comprehensive array of tools that can be used to manage the system. Perhaps some of those are having some interesting quirks into how the system performs. Very interesting in my opinion, and we're going to dig deeper into this, and hopefully we'll see some other quirkiness and some other funky behavior on the other Zen 3 laptops that we're looking at over time, because this is quite new, quite unique. Something that obviously we saw with Ryzen 4000, the Stapham and the STT, for example, but it's very different how we typically look at Intel laptops and how we look at desktop systems. So it's really cool to see the different operating modes that we still get from the fundamentally similar Zen 3 core and the 7nm TSMC technology. But anyway, that's enough of me rambling on. Let us know what you think in the comment section down below. Do you think it's really cool how the processors basically go pedal to the metal, really high power, really high clock speed, and then drop down just to keep everything in check? Or would you rather more consistent workload at perhaps a lower average, like the 35 watt TDP manual mode that we run? Let us know in the comment section down below, and let us know if you think this would influence your workload, where you get that spiky peak and trough behavior, or whether you think continuous frequency behavior is going to be more important for your workload. Let us know. Sound off in the comment section down below. Check back for the full video review and the written review in the coming days. If you have any interesting tests you want us to run, let us know before I finish up the testing and get working on the video. But basically, some quirky behavior that we've seen thus far. However, Ryzen 9 5980HS in this sleek laptop looks like an absolute performance monster. So I've been Luke Hill for Kit Guru. Thank you for watching this quick hands-on video of Ryzen 9 in the Zen 3 mobile form. Check back, like, subscribe, do all our YouTube stuff, check out the Kit Guru website, support us on Patreon, interact with us on Discord and the likes, buy a cool t-shirt if you want to really help us out, and make sure you check back in the next one. I'll see you soon.